in this video, I'll be going over the LeetCode problem 2sum2, import array is sorted. So first, let's read the question. Given a one-index array of integers, numbers, that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. And let these two numbers be numbers index 1 and numbers index 2, where 1 is less than index 1, one is less than equal to index 1, less than index 2, which is less than or equal to number_length. Return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array of length 2. And they mentioned that the tests are generated such that there's exactly one solution, and that we may not use the same element twice, and that the solution must only use constant extra space. So let's take a look at example 1. So here the input numbers is an array of 2, 7, 11, 15, and the target is 9. And we see that 2 and 7, they add up to 9. So we return 1, 2. And the reason is that, like they mentioned up here, it's one index. So instead of starting at index 0, they start at index 1. So that's why we return 1, 2. So let me go to the whiteboard and let me explain how I'm going to solve this problem. So we're going to have two pointers, a left pointer and a right pointer. The left pointer is going to start out at 0, and the right pointer it's going to be initialized to len numbers -1. So basically, left is going to be the first index, and right is going to be the last index. And what we're going to do is we're going to loop through the numbers array. So, and with one condition, well, as long as left is less than right. And so what we're going to do is we're going to get the sum of the elements at the two indices. So I'll just say sum. And I'm going to prove it numbers to num, left. We're going to take the sum of the elements at these two indices, right? And we're going to do a check. So if the sum is equal to target, then we just return left +1, right +1. And again, right, the reason is because we're supposed to return the indices as a one index array. But in our case, we're still considering them as 0 index. So we need to increment each index by 1. However, if the sum is less than target, well, if the sum is less than target, we know that we need to increase the sum. And remember, we know that there has to be exactly one solution. So because we need to increase this sum to match this target, we're going to have to increment left by 1. Oh, sorry, this should be Elif. And the opposite is true. If sum is greater than target, we need to decrement right by 1. So else. And the reason for this is because if sum is greater than target, then we need to find a way to decrease the sum. And the way we do that is to decrement the right pointer. And so let me do an example real quick. So suppose that we have this input array. And let's say our target is equals to let's say 8. So our left, I'll abbreviate it as a L, is set to initialize to 0, and the right is initialized to 3. So on the first iteration, our sum is going to be 1 plus 6, right? And since we know that 7 is less than 8, this means that we need to increment the left counter by 1. So now left is now 1. And now let's look at the second iteration. So this time, sum is equals to 8 because it's 2 plus 6, right? And since 8 equals to 8, we just return left plus 1 and right plus 1. So this would be 2, 4. Because again, if you use one, if you look at this by one index, this is the second index and this is the fourth index. So now let me code this up. So like I mentioned before, we're gonna have two pointers, a left and a right. Left is going to be initialized to 0, and right will be initialized to the last index of the ring. And we're gonna loop through the array. And to be honest, like you could even put while true here, just because like we know that there has to be exactly one solution. So you can even put while true here, but it's probably better to do while left is less than right. So I'm gonna get the sum of the elements of the two indices. And if res is equal to target, we return left plus 1 and right plus 1. If res is less than target, like I mentioned before, we need to increment left by 1 because we need to find a way to increase this sum. In this case, I call it res. And because we know that all the elements are sorted in ascending order, or I guess not decreasing order, we can increase this res by incrementing the left pointer, or moving the left pointer rightward. And the reverse, or the opposite is true as well. If the sum is greater than target, or res is greater than target, then we need a way to decrease the sum. And in that case, we can just move the right pointer one left to make the number smaller. So let me just do a quick demo test to make sure I didn't mess anything up. Okay, looks good. I'll submit it. And yeah, you can see that this is a pretty efficient solution. The time complexity is O of n because we're looping through the array at most once. Thank you all for listening.